Ground Fault Circuit Interrupter, or GFCI, is designed to protect people from electrical shock. It does this by monitoring the current flowing into and out of a circuit. If there is a difference of more than a few milliamps, the GFCI trips, cutting off the power to the circuit. Several factors can cause a GFCI receptacle to trip when a hot plate is plugged in. Firstly, the GFCI receptacle itself may be faulty. Even with a normal load, a defective or damaged GFCI can trip. To test this, use a GFCI tester. If the tester indicates a fault, replace the receptacle. Secondly, the hot plate may have high leakage current. Some hot plates have slightly higher leakage currents that could exceed the sensitivity threshold of the GFCI, causing it to trip. To determine if the hot plate is producing excessive leakage current, use a leakage current tester. If the leakage current exceeds the GFCI's threshold, the hot plate may need to be repaired or replaced. Thirdly, there could be a grounding issue. A loose or non-existent ground connection on the hot plate or in the electrical system could allow small amounts of current to flow through the GFCI, causing it to trip. Ensure that the hot plate is properly grounded and that the electrical system has a reliable ground connection. The National Electrical Code, Section 250.4 A5, requires that all non-current carrying metal parts of equipment be grounded. Fourthly, overload can be a cause. While the hot plate is rated for 11.3 amps, it may draw slightly more current during initial heating or if it is damaged. This could exceed the current rating of the GFCI receptacle. Check the current rating of the GFCI receptacle and ensure it is adequate for the hot plate. Fifthly, electrical interference from nearby electrical devices or appliances may be generating electrical noise or harmonics that could interfere with the GFCI's operation. Look for any nearby electrical devices or appliances that may be generating interference and consider relocating the hot plate or removing potential sources of interference. To further troubleshoot, plug the hot plate into a different GFCI receptacle in a different location to eliminate the possibility of a faulty receptacle. Also, borrow a different hot plate to see if the problem persists. If the other hot plate does not trip the GFCI, it indicates an issue with the original hot plate. When checking the grounding, ensure that the ground wire is properly connected to the hot plate and the electrical panel. Use a multimeter to test the continuity between the hot plate's ground terminal and the ground bus in the electrical panel. The resistance should be very low, ideally less than 1 ohm. Refer to NEC section 250.122 for proper sizing of equipment grounding conductors. If the hot plate is drawing more current than its rating, it may be necessary to use a larger GFCI receptacle. However, it is important to ensure that the wiring in the circuit is also adequate for the increased current. Refer to NEC table 310.16 for allowable ampacities of insulated conductors. If electrical interference is suspected, try using a line filter or surge protector to reduce the noise on the electrical circuit. Ensure that the line filter or surge protector is properly grounded. Also, make sure that the GFCI receptacle is properly wired. Incorrect wiring can cause the GFCI to trip even with a normal load. The line and load wires must be connected to the correct terminals in the GFCI receptacle. If the hot plate has a 3-prong plug, make sure that the grounding prong is not broken or damaged. A broken or damaged grounding prong can prevent the hot plate from being properly grounded. If the problem persists, it may be necessary to consult with a qualified electrician to diagnose and repair the issue. An electrician can use specialized equipment to test the electrical system and identify any faults or problems. Remember that working with electricity can be dangerous. If you are not comfortable working with electricity, it is best to consult with a qualified electrician. Also, be sure to follow all safety precautions when working with electricity, such as turning off the power to the circuit before working on it. If the hot plate is used frequently, it may be necessary to replace the GFCI receptacle more often. GFCI receptacles can wear out over time, especially if they are subjected to frequent tripping or surges. It is also important to use a GFCI receptacle that is rated for the environment in which it is being used. For example, if the hot plate is being used in a damp location, it is important to use a GFCI receptacle that is rated for wet locations. The NEC requires GFCI protection in specific locations, as outlined in Section 210.8. This includes bathrooms, kitchens, garages, and outdoor locations where electrical receptacles are installed. When testing the GFCI receptacle, use a GFCI tester that is designed to test the specific type of GFCI receptacle that is being used. There are different types of GFCI receptacles, such as those that are designed for residential use and those that are designed for commercial use. If the hotplate is used in a commercial setting, it may be necessary to use a commercial-grade GFCI receptacle. Commercial-grade GFCI receptacles are designed to withstand the rigors of commercial use and are typically more durable than residential-grade GFCI receptacles. When selecting a GFCI receptacle, choose one that is listed by a recognized testing laboratory, such as Underwriters Laboratories or Canadian Standards Association. A listed GFCI receptacle has been tested and certified to meet safety standards. If the hotplate is connected to an extension cord, make sure that the extension cord is properly sized for the current that the hotplate is drawing. An undersized extension cord can overheat and cause a fire. Refer to NEC Table 400.5. For allowable ampacities of flexible cords and cables. It is also important to keep the GFCI receptacle clean and free from debris. Dust, dirt, and other debris can accumulate inside the GFCI receptacle and cause it to malfunction. To clean the GFCI receptacle, turn off the power to the circuit and use a vacuum cleaner to remove any debris. If the hotplate is being used in an area with poor ventilation, it may be necessary to install a ventilation fan to remove heat and moisture. Excessive heat and moisture can damage the GFCI receptacle and cause it to malfunction. If the hotplate is being used near flammable materials, it is important to take precautions to prevent a fire. Keep flammable materials away from the hotplate and never leave the hotplate unattended while it is in use. Also, be sure to have a fire extinguisher nearby in case of a fire. If the hotplate is being used by children, it is important to supervise them closely. Children should not be allowed to operate a hotplate without adult supervision. If the hotplate is damaged, it is important to have it repaired by a qualified technician. Do not attempt to repair the hotplate yourself, as this could be dangerous. If the hotplate is no longer needed, it should be disposed of properly. Contact your local waste management company for information on how to dispose of electrical appliances. By following these troubleshooting steps and safety precautions, you can help to prevent GFCI receptacles from tripping when a hotplate is plugged in and ensure the safe operation of electrical equipment. Always consult with a qualified electrician if you have any questions or concerns about electrical safety. The National Electrical Code is updated every 3 years, so it is important to stay up to date on the latest requirements. You can purchase a copy of the NEC from the National Fire Protection Association website. In addition to the NEC, there may be local electrical codes that apply to your area. Contact your local building department for information on local electrical codes. Remember, electrical safety is everyone's responsibility. By following these guidelines, you can help to keep yourself and others safe from electrical hazards. If the hotplate is plugged into a multi-outlet adapter, this could also be a contributing factor to the GFCI tripping. Multi-outlet adapters can sometimes create ground loops or increase leakage current, leading to nuisance tripping. Try plugging the hotplate directly into the GFCI receptacle to rule out the adapter as the cause. It's also worth noting that some older GFCI receptacles may be more prone to nuisance tripping than newer models. If the GFCI receptacle is several years old, consider replacing it with a newer, more sensitive model. When replacing a GFCI receptacle, be sure to choose one that is rated for the appropriate voltage and amperage for the circuit. The voltage and amperage ratings should be clearly marked on the GFCI receptacle. Additionally, ensure that the new GFCI receptacle is compatible with the existing wiring in the electrical box. Some GFCI receptacles require a neutral wire connection, while others do not. Choose a GFCI receptacle that matches the wiring configuration in your electrical box. Before replacing any electrical components, it's always a good idea to turn off the power to the circuit at the circuit breaker. This will help to prevent electrical shock. After replacing the GFCI receptacle, test it to make sure it is working properly. Use a GFCI tester to verify that the receptacle trips when the test button is pressed. If the receptacle does not trip, there may be a problem with the wiring or the receptacle itself. If you are unsure about any aspect of electrical work, it's always best to consult with a qualified electrician. An electrician can safely and accurately diagnose and repair any electrical problems. Always prioritize safety when working with electricity.